I'm going to work another one from your book to give us another opportunity to try that problem format. And again, I'm going to pull from the book because I'm not really happy with the PowerPoint. So I'm going to choose to read 1410, same page. Consider the reaction N2O4 in equilibrium with two NO2s. And they give us a Kc. They give us initial concentrations and ask us to find, ooh, it's thunder booming out, to find the equilibrium concentration. So I'm going to turn this, and again, I'm just going to keep the book handy to record what we have. N2O4 in equilibrium with two NO2s. Kc is given as 0.36. I'm also told the initial concentration of NO2 is 0.1 molar. I have no N2O4. Find the equilibrium concentrations of reactant and product. This is all we know. The initial amount of the left side of our arrow is 0. We have product. Friends, the only possible direction of this reaction is to go from right to left. Right to left. There is no forward reaction because there's 0 there. So that's important to say that it's this side that's going to go down and it's this side that's going to go up. That if the reaction is proceeding from right to left, we call it the reverse direction, the NO2 gets consumed as the N2O4 gets made. Notice where the coefficient of 1 is located. The coefficient of 1 is located at N2O4. Its value will be x. The coefficient of 2 has to stand for 2x. So at equilibrium, the concentration of our reactant is x, and at equilibrium, 0.1 minus 2x represents the concentration of N2O2. The Kc expression, even though it's proceeding from right to left, we still read it products over reactants. That it will be the concentration of NO2 squared set over the concentration of N2O4 at equilibrium. Kc was given as 0.36. 0.36 is 0.1 minus 2x squared. And I'm going to write that out twice to emphasize that we're squaring the top. Plus, it helps me to FOIL. Set over the concentration of equilibrium value of x for our N2O4. Let's simplify the top. 0.1 times 0.1 is multiplying the first in our FOIL, 0.01. 0.1 times negative 2 is negative 0.2x. 0.1 times negative 0.2 is negative 0.2x. Negative 2x times negative 2x is positive 4x squared, foiling the top. Now certainly we can combine this like term in the middle, 0.01 minus 0.4x plus 4x squared set over x is equal to 0.36. Simplify a little further. 0.01 minus 0.4x plus 4x squared is equal to 0.36x. Let's bring the 0.36x to the left side so we can set it equal to 0 and get our quadratic equation set up. So 0.36, if you just hit that 0.4 minus 0.36, well, that's negative though. Negative 0.4 minus 0.36 is going to give us negative 0.76 when we combine those like terms. So we have 0.01 minus 0.4x minus 0.36x plus 4x squared. That's bringing this over to the left side. And we said to combine those like terms, and this is what we see. So the value of A is positive 4. the value of B is negative 0.76, and the value of C is positive 0.01. Using your quadratic equation, let's see what we get. Value of A is 4, negative 0.76, and positive 0.01. We come up with two possible answers, 0.014 and 0.175. One of them will make no sense. Go back to the original grid and you'll see which one it is. If the original concentration was 0.1 and it's proceeding from right to left, it's going to get consumed. The second number makes no sense. I can't have a bigger number. I can't end up with a negative molarity. So X, from our quadratic formula, comes out to be 0.0142 molar units. I go back to the equilibrium value. The concentration of N2O4 at equilibrium is the value of X. So that's 0.0142 molar units. 0.1 minus 2 times our value of X leaves us an equilibrium concentration of NO2 to be 0.716 molar units. Lots of algebra in this chapter. It's fun, don't you think, math majors?